Hey guys, today I want to go over gravity and motion in space. Once again, we followed along in the guided notes that you got in your packet here. We'll go ahead and get started here. So each planet spins on its axis. Okay, so axis is going to go here. And the spinning of a body, such as a planet, on its axis is called rotation. One of the things you're going to need to know is the difference between rotation and revolution. This is important. We've already talked about orbit so far, but orbit is the path that a body follows as it travels around another body in space. Okay, so this, for example, would be the sun, the Earth traveling around the sun, or the Moon traveling around the Earth. Okay, and this completed path of an orbital path is called a revolution, which is one complete path. Okay, so that is the revolution. So the difference between rotation and revolution: the Earth spins on its axis in a rotation, and the Earth spins around the sun in a revolution. Okay, moving on. It is imperative that you know Kepler's three laws of motion. So Johannes Kepler discovered these three laws of planetary motion. So that would be right here, Johannes Kepler. I'm going to move down in this. So law number one states that orbits of the planets are in an elliptical pattern, which simply means that the orbit is an oval shape. Okay, and you can see that oval shape in both here and in your notes, and you can put it down here. So an orbit is an oval shaped path. Okay, moving on to law 2. Kepler's second law states that a planet moves fastest when it's near its perihelion and slowest when it's near its aphelion. So you can move that here. And the definition of perihelion is the moment that it's closest to the sun, and the aphelion is the moment where it's furthest away from the sun. You can see in these diagrams here that you can the oval or elliptical pattern of the orbit is here. The sun is right here and right here in those situations. And this here would be the perihelion, where it's closest to the sun. This here would be the aphelion, where it's furthest away from the sun, and you can put those in right here. Moving on to the third law, planets that are farther away from the sun take longer to orbit. So we're not talking about in relation to the orbital pattern here. We're talking about the actual distance from the sun. Okay, so for example, Mercury is the closest planet to the sun and takes just 88 Earth days to complete an orbit, but Neptune is furthest out and takes 164 years to make the same trip. Okay, moving on. So Kepler did not actually understand what caused the planets to move this way. He just was able to identify that this occurs. The man who was able to identify why this happens is Isaac Newton. Okay. So Newton was the first to test and theorize the universal law of gravitation. Okay, and the universal law of gravitation states that gravitational force decreases with distance and it increases with mass. So gravity is based on two things: distance and mass. Okay, I'm going to keep moving here. Oh, you can plug those in to these areas of the notes. So the direction of the pull of gravity is always towards the center of mass, meaning everything in this is going to get pulled towards the middle. And you can put those in here. Let's figure out where we're going here. Sorry. Okay, so we have a couple questions about this. If gravity is pulling Earth towards the center of the sun, why does Earth move in a circle? And why doesn't Earth crash into the center if it's being pulled towards the center? Well, if the forces acting on Earth were balanced, then the Earth would move through space in a straight line, okay? And at that consistent velocity. But the Earth is trying to move past the sun. It's just that the gravity of the sun is pulling Earth around it, okay? We call this idea of wanting to continue on the same path that you're on inertia. And inertia is an object's resistance to change in speed or direction until acted upon by an outside force. Okay, this is also Newton's first law of motion when you get to physics. It says that an object in motion tends to stay in motion unless acted upon by an unbalanced force. And this is going to continue to happen because there's nothing in space to stop this from happening like there is on Earth. Think water resistance or friction of some sort, or air resistance, which is another type of friction. Okay, gravitational attraction keeps the planets in their orbits, and inertia keeps them moving along their orbits. And those will go here. Okay, so there are no other forces acting on Earth because there's no friction in space. Space is a vacuum, so there's no particles to keep these things from being resistive on. Okay, the attraction of gravity between two masses stays the same as long as the distance stays between them. And as long as there's no outside interference, the distance will continue to remain the same. Earth must move in a circle to maintain its distance from the sun, because that is the law of gravity at work there. Okay, so the force which keeps an object moving in a circle is called centripetal force. Think about if you were to have a bucket of water and you were to fling the bucket of water around your head, the water stays in that bucket due to centripetal force. These videos that are in the link here that you can see will be posted on the website so you can see that. So Earth must maintain a circle in order to remain in the same distance from the sun. Okay. We don't really need this here, but we'll move into retrograde motion. And retrograde motion is the apparent westward motion of the planets with respect to the stars. Retrograde motion usually means that motion which is contrary to the rotation of the primary movement that the object's on is what forms the system's hub. Think, if it appears to be moving in that direction, it will move in the opposite direction is what retrograde motion states. Okay, and furthermore in this presentation, there is some information about SOHO and the Hubble telescope. I implore you to check out some of these photographs if you want to see what these things look like. So SOHO is the Solar and Heliospheric Observatory. These are some pictures. It's used to pretty much take pictures of the sun so that we can study those. Here are some images, and you can check out online, just Google SOHO images and it'll show you. There are also some images about the Hubble Space Telescope, which I encourage you to go look at, because as you can see from these examples, it is a very pretty sight to go out and see these. All right, that's all for these notes. Thank you very much.